All welcome to another session with me, Varun on Tech Tablet. Well, it's been a while that I've put out any videos thanks to, whatever my schedule has been. But then here is the time for us to come out on something new. And with regards to that, I'll be quickly sharing my screen. So I've been having a lot of queries of late with regards to how to do a project on data science. So I've decided that I'll float some videos on how to do a project which are already done or which have been created by some users or some websites on the internet. Now, this project is by medium.com. And as you can see, this project talks about loan prediction, which means that it will be falling into the finance domain. And here we would be using decision tree and random forest. I repeat, this code is not owned by me. I am just trying to explain this code from Google. So here, what the author is trying to do is he's considering a data set, minted by lendingclub.com in the year 2016. And here's the code, right? You could probably download the data set here. As you can see, it's pretty clearly written here. And when you go into this website or when you go into that hyperlink, it will directly download it. I mean, you could directly download it um, uh, from a Google Drive. Now, again, coming here, as you can see, this data set in specific has a lot of, variants of, data that you can work on. Just to be a bit precise on that. So as you can see, you have, the purpose. I mean, you have float values, you have text values, you have integers, you have, binary. So there's a lot for you to experiment. There's a lot for you to work on considering this data set. Now, every column is to be understood separately. So here, if you can see credit policy, if it is one, then the customer meets the credit underwriting criteria. Otherwise, he's not meeting the credit criteria. Then there's the purpose, interest rate. So everything here is very well defined. This is known as a technical document about what your data set represents or what your data set means. I think this is a very essential part for you to understand before you jump into working on a project. It's not just for this. When you're working on any project, I think the first step for you is to understand the data set and what do you have to do, which is exactly what the author is trying to show here. Now let us quickly get into our code. It is exactly the same code, right? So I've imported the libraries just like them, whatever have been specified. And then I read the CSV. It's a loan data.csv. From now on, I would be checking the whereabouts, or I would be digging deeper into the data set to understand what this data set has for me. Right now, keeping that in mind, the first thing that I would be checking out is information. And here I would be seeing if there are any null values and what is the data type, how many columns I have, how many rows I have. All that can very clearly be understood from this specific point. So as you can see, my data is, or my data set is currently a data frame. It has 9,578 values spanning from 0 to 9577. There are, like 13 columns or 14 columns. 0 to 13 is 14. You do not have any null values anywhere. You can see that it is non-null, but you have a range of data types that you can practice on. You have right from integer to object, float. As I said, right, you have a wide variety of data set that you can work on. Now, when you just, use describe function, you would be able to check the count, mean, standard deviation, the minimum, 25, 50, and 75% of the value and its maximum value. All right. So here, all the columns have 9,578 values or rows. That's the count. And here you could see the mean of each and every column specifically, then the standard deviation, the minimum value. So the minimum value of annual income, logarithm of annual income is 7.5, while the maximum income is 14.5. All right, so that's how it goes. Then I'm just checking the top 5 values just to see if I have everything in place or if there's a problem, or if, just to check. Now that I have my data well read and that my system has processed the information, I would now get into EDA, which is exploratory data analysis. Now, EDA generally talks about, or EDA works on how to understand the concept, or no, not concept, rather how to understand the facets of your data, right? Like what is higher, what is lower, which is greater, which is not, or which is in time, which is not in time. You want to check things like that, how many people have paid within time, or how many people are defaulters, or how many are male, female, children, married, unmarried. For all these kind of understanding, you would have to get into EDA, which is exploratory data analysis. Now, having said this, I would be using a histogram, as you can see here. And here I am trying to check the FICO. Okay. FICO is, this being financial domain, it talks about, it's a score, some Isaac score. I don't think we should delay such questions. So let me go ahead and check the abbreviation of, yeah, it is Fair Isaac Corporation, and they have developed a method of calculating credit scores based on information, right? So here, this would all, you could also use this in your interviews, like what is FICO and how you try to assess it. Anyways, not completely deviating from the subject, I am just making, or I'm trying to come out with two different plots here, as you can see, both being histogram, but with different color representation. I'm also using this to see if, to mark what are the different color, readings that I have, right? And here you can see how there's a huge difference between people who have a credit policy of 1 and people who have a credit policy of 0, right? And just to be sure if they're marked right, you can use legend, as I said, and legend would, legend would give you this box here, which would kind of give you the values of what it basically gives you a color coding, right? Now, I'm now checking for another set of values here. So you can see I want to see those who have not fully paid versus those who have fully paid. So I'm just switching the binary value from 0 to 1, and you can see how there is a substantial difference of people who have paid versus people who have not paid, right? You can see that this is an overlap, and it's as worse as it gets. Now, again, this does not mean that he's a defaulter. It's probably that the banks have lent out loans to too many projects or people or firms or individuals. For example, even a credit card is considered a loan. A personal loan, you have marriage loans, you have short-term loans, long-term loans, housing loans. So yes, I think the distribution seems to be fine. Now we'll also have to check what are the different types of loans that people have taken, and out of which how many people have paid and not paid. So we'll go into categorical understanding. So for that, I'll be using count plot on my data. I'll be using the different types. As you can see, debt consolidation, credit card, home improvement, small, major, education. So these are the different types of loans that you have. And in each of these, you can see how many people have paid and not paid. That's exactly what we're doing here. So X would be the purpose, which is the reason why you have different types of loans specified here on the X-axis, while on the hue, which is, as the criteria, I'm considering the values which have not been fully paid. And I'm also able to see that 0 are the people who have not paid, while 1 is the people who have paid, right? And the source of data is loans, which is the data set that is in my data frame right now. The next one that I'm using is a joint plot. This is basically used to understand the relation between FICO and interest rate, right? Now, this is exactly the same steps that have been followed here. You can, just probably see. And from this graph, it is being deduced that as FICO score increases, the interest rate tends to decrease, which is probably the similar output that we have. So you can see that with the increase of your FICO score, the rate of interest is coming down, right? So that's probably because you've been a good customer and you've always been repaying on time. So your credibility is high, because of which you would be charged a low rate of interest, which is probably otherwise if you're not a good customer. I'm not stopping here. It's going further into LM plot. But here, when I'm using LM plot to check, the interest rate and the FICO, I see that there's not a huge difference between the people who've paid and who've not paid, right? Like they look pretty much similar. So now that I've understood the basics of my data, I would now be going ahead. Assuming you are working for a client, or probably you are working on a project in your finals, or probably for a competition or whatever, you would be have to, you would have to give a very clear cut understanding of what those graphs mean. Interpretation is probably the key. You cannot just assume that it is being understood automatically, right? Now I would be checking the information once again. I see that all my columns are just like that, no huge changes. But then there's a catch here. There is one column which is called purpose, right? Let us just take a look at what that column is before we kind of move forward or move ahead. So purpose is a categorical, I wouldn't say it's a categorical column, or probably it is, because I see that there are 1, 2, 3, 4, like around 4 or 5 varieties of information within purpose column, right? Which is this column. So now I would probably have to, uh, decompartmentalize it, or probably I would have to expand the features within it. So what I'll do is I'll be pushing this column into a list, naming it as categorical features, and then we'll be using get dummies, right? Get dummies, what it does is it kind of exchanges the value as a column, and you would be having a larger data set with new columns, right? So here now you can see that instead of 14 or 0 to 13, we now have 0 to 18, right? Values from here probably are the values which were in the purpose column that have now come up as columns, right? So having done this, now it's time to get into the crux of the algorithm, wherein you would be using train test split. This is basically, so what you're doing here is assuming the data is 100%, you would be compartmentalizing it or breaking it into 2 parts when you have the test and the train. Generally, or I would say 99%, the train data is much higher or significantly higher than the test. So if the train is probably 60 to 80%, the test occupies the rest of the place. You would have to train the data on the input and the output, so it is able to predict in a better way. So here what I'm doing is I'm training the decision tree first. So here, prior to that, as you can see within my X, I am using all my variables, my independent variables, and within Y, I'm using not fully paid, right? So now having said this, now I would be using my test train split. And as you can see, the test size is 30%, which obviously means that the train size is 70%. This step being done would automatically take us into the next part, which is using the machine learning algorithm, that is a decision tree classifier. So I will be using a decision tree here first, importing the required library, after which passing it into a variable. Now I'll be fitting this to my train values. And when I execute this, you would be able to see that this is executed. I mean, X train and Y train have the decision tree algorithm fit into it. Going ahead, I would now be predicting the values on test. Please mind you here, when you're working on this, you would be fitting the value to the train while you would be predicting the values on test, right? Then you would be using the matrix, which is also part of sklearn library. Sklearn does not just have machine learning algorithms, but it also has evaluation algorithms for machine learning. So sklearn can be called as the mother of machine learning libraries. So in it, I have matrix within which I'll be using classification report and a confusion matrix. Each of these have a deeper statistical understanding. Both of them are kind of used in the end to find out how your algorithm is performing, right? Now, when I use a classification report, it will give me the above four values, that is precision, recall, F1, and support, right? And then I would be checking my confusion matrix, and this would give me an accuracy score. And as you can see, my accuracy is at 84.6, right? Now, this is for a decision tree. But then we are not done yet. I would be getting into my random forest model. And because random forest is a different algorithm, it's a part of ensemble trees. I would be using sklearn.ensemble, and here I would be importing random forest classifier. Again, random forest classifier, when you're using it, you need to specify how many estimators or how many trees are you looking at. Okay, I am trying to generate 500 as the quantity. I have my X train, Y train values on which I am fitting the model, right? RFC is the variable. So random forest classifier, done that. Now, obviously, the next step, now that you have fit the model on the train values, or you fit the algorithm on the train values, the next step would be to predict the values. So here I'm using predict on my test once again. This does not change, at least as far as machine learning is concerned. You train the values on the train data set, and you predict the correctness of these values on the test data set, right? And then I will be using my matrix from my sklearn once again. I'll be importing classification report and a confusion matrix. And then I'll be, using my classification report to generate these values, which is not the end of it. In my next step, I'll be using confusion matrix, which will again get me an accuracy score of the current model. So as you can see, if decision trees has given me an accuracy of 84.6, my random forest has given me an accuracy of 84.7. Okay. So now I think it is, pretty much the same values here. You may have a difference, a tad bit of difference in values when you're executing each and every time, because the values that go into the data set are at random. So there is no hard and fast rule that, what values you see here is exactly the values you'll be having there. For example, here you see that the weighted average precision is 75 for decision tree, right? So you have 85, 19, 52, 75. These values, may tend to change a bit, right? But then just because the values are different does not mean your algorithm is wrong, right? So here you can see how they have, given us an understanding of what these are. So when we look at the recall of single decision tree model, the class 1 did better with 0.23 than random forest, but the same observation is applicable to F1 score. But when we look at the overall average, it wouldn't be wrong to say that random forest did better, which is exactly what we've been discussing. So yeah, I think now you know how to work on probably decision trees or random forest. Again, please note that your EDA or the steps that involve may completely vary with the data set or with the kind of values you have within the data set and what output it is that you're looking for. So in the next video or probably in the next algorithm, we'll be discussing an entirely new data set and also probably from a different website. I'll also be quoting this website in the comment section below, just in case you are looking forward to learn from the website parallelly. Then I think I would encourage you to do that as a practice rather than just as a copy. Also, if in case you are planning or if in case there's any questions or probably you're looking forward to reach out to me, please let me know in the chat box, or you could also reach out to me on Instagram, and I'll be more than happy to assist you or probably to get back to you. Thank you all. See you again very, very soon.